Question: the pH of a buffer solution containing 0.1 m CH3COOH and 0.1 m sodium acetate is 4.74. What will be the pH if 0.05 mole of HCl is added to 1 liter of this buffer solution? Acid dissociation constant for acetic acid is given as 1.8 into 10 to the power minus 5. Now in this question it is given that 0.1 m acetic acid and 0.1 m sodium acetate solution is taken, which is acting as a buffer solution. This is acting as a buffer solution, and pH of this buffer solution is equal to 4.74. Now what is asked in this question? What will be the pH? Means you have to find the pH if amount of HCl added is 0.05 mole of HCl and this amount of HCl is added to 1 liter of the buffer solution. Acid dissociation constant is given as 1.8 into 10 to the power minus 5. Now the reaction that takes place on adding HCl is sodium acetate, that is CH3CONA, reacts with HCl to give CH3COOH plus NaCl. Now initially what is the amount of sodium acetate present? It is 0.1 mole. Amount of acetic acid present is 0.1 mole. Now from the stoichiometry of the reaction, 1 mole of sodium acetate reacts with 1 mole of HCl to give 1 mole of acetic acid and 1 mole of NaCl. Now what happens when 0.05 mole of HCl is added? On adding 0.05 mole of HCl, 0.05 mole of HCl reacts with 0.05 mole of sodium acetate to give 0.05 mole of acetic acid. So final concentration of sodium acetate is 0.1 minus 0.05, which is equal to 0.05 moles. Final concentration of HCl is 0.05 minus 0.05, that is 0, because all the HCl has reacted with sodium acetate. And acetic acid, initially it is 0.1 mole per liter. Now since 0.05 moles is formed when HCl reacts with sodium acetate, 0.05 moles of acetic acid is formed. So final concentration of acetic acid will be 0.1 plus 0.05. This is equal to 0.15 moles per liter. Now pH of the solution will be pKa plus log salt divided by acid. That is concentration of the salt divided by acid. pKa means log 1 by Ka. What is the value of Ka? 1.8 into 10 to the power minus 5 plus log. What is the concentration of the salt? Concentration of the salt is 0.05, that is sodium acetate. So this is 0.05 divided by what is the concentration of acid? Acid is acetic acid, so its concentration is 0.15. pKa value is 4.745 plus log 0.05 divided by log 0.15 is equal to minus 0.477. Solving, the value of pH is 4.268 and this is approximately equal to 4.27. So 4.27 is the pH. Now how to find log 0.05 divided by 0.15? This will be 5 divided by 15 and 5 ones are 5, 5 threes are 15. So this becomes log 1 by 3. Log 1 by 3 can be written as log 1 minus log 3. Log 1 is 0 minus log 3 is 0.477. So The answer is minus 0.477. This is the value of log 0.05 divided by log 0.15. The concentration of hydrogen ion in a 0.2 m solution of formic acid is 6.4 into 10 to the power minus 3 mole per liter. To this solution, sodium formate is added so as to adjust the concentration of sodium formate to 1 mole per liter. What will be the pH of the solution? The dissociation constant of formic acid is 2.4 into 10 to the power minus 4 and the degree of dissociation of sodium formate is 0.75. Given is the concentration in the question. Concentration of formic acid is given as equal to 0.2 m. Concentration of sodium formate is given as 1 mole per liter, that is 1 m. Value of acid dissociation constant for formic acid is given as 2.4 into 10 to the power minus 4 and degree of dissociation of sodium formate is given as 0.75. This is the degree of dissociation of sodium formate. So, sodium formate dissociates to give formate ion and sodium ion. So, if alpha is the degree of dissociation, then at equilibrium, the various ions present and undissociated sodium formate present will be C. C represents the concentration of the sodium formate multiplied by 1 minus alpha, and this will be C alpha, this will be C alpha. Now in the question it is given that value of concentration is 1 m. Here it is given that value of concentration of sodium formate is 1 m. So putting the value of concentration equals to 1, this becomes 1 minus alpha, this is alpha, this is alpha. Now what is the value of alpha? What is the value of alpha given in the question? It is given as 0.75. So this becomes 1 minus 0.75, this is 0.75 and this is 0.75. So 1 minus 0.75 is 0.25. Now what is the formula of pH? pH is equal to pKa plus log salt, concentration of the salt divided by concentration of the acid. So pKa means log 1 by value of Ka, that is 2.4 into 10 to the power minus 4 plus log, what is the concentration of the salt? Concentration of the salt will be 0.75 divided by concentration of the acid. Concentration of the acid is 0.2. So pKa value will be equal to 3.62 plus log 0.75 divided by 0.2 is equal to 0.574. This is 0.574. Now adding the values, the value of pH will be 4.194 or this can also be written as 4.19. So pH of the solution is 4.19. This buffer solution, that is combination of formic acid and sodium formate, is acidic buffer. HCOOH is the weak acid and HCO minus ion is the conjugate base. So weak acid and conjugate base, or the salt of weak acid with a strong base. So this combination, that is weak acid and its conjugate base, forms acidic buffer. What happens on adding HCl? For example, any acid is added to the buffer solution, then this HCO minus ion will combine with the H plus ion of the acid to give HCOH and Cl minus ion. So this is how the pH is maintained. Whatever extra H plus ion is added will be removed from the solution. Here in the concentration of the salt, that is pH is equal to pKa plus log salt by acid, the concentration of the salt is actually the concentration of this conjugate base in the solution. Therefore, here the concentration of the salt is taken as 0.75. When 0.20 m acetic acid is neutralized with 0.20 m NaOH in 0.50 liter of solution, the resulting solution is slightly alkaline. Calculate the pH of the resulting solution. Now, molarity of acetic acid solution is given as 0.2 moles per liter. Molarity of NaOH solution is given as 0.2 moles per liter. And volume of solution is given as 0.5 liter. Now, what happens when acetic acid is neutralized with NaOH? When acetic acid is neutralized with NaOH, then sodium acetate salt is formed. Now, acetic acid is a weak acid, sodium hydroxide is a strong base. From the stoichiometry of the equation, it can be seen that 1 mole of acetic acid reacts with 1 mole of NaOH to form 1 mole of sodium acetate and 1 mole of water. Now, initial concentration of acetic acid is 0.2 moles per liter, NaOH is 0.2 moles per liter, but the volume of the solution is 0.5 liter. Volume of the solution when they are mixed is 0.5 liter. So, moles of acetic acid present in the solution will be molarity into volume, that is 0.2 into 0.5, which is equal to 0.1 moles. So, 0.1 mole of acetic acid and 0.1 mole of NaOH is present, and 0.1 mole of acetic acid will react with 0.1 mole of NaOH to give 0.1 mole of sodium acetate. Now, this sodium acetate in the presence of water will form a weakly dissociated acetic acid and a strong base, that is NaOH, because of which the solution will be basic, because the base formed is a strong base which remains dissociated to give Na plus and OH minus ion. Now, moles of sodium acetate present in the solution is 0.1 mole and volume of the solution is 0.5 liter. Therefore, molarity of the sodium acetate solution or the concentration of sodium acetate in moles per liter will be moles of sodium acetate divided by volume of solution, which is 0.1 divided by 0.5, that is 0.2 moles per liter. This is the concentration of sodium acetate. Formula for pH is half in brackets pKw plus pKa plus log A. What is pKw? pKw is minus log Kw, and Kw value is 10 to the power minus 14. So, minus log 10 to the power minus 14 will be 14. pKa is minus log Ka. pKa is equal to minus log Ka, and value of Ka is given in the question as 1.8 into 10 to the power minus 5. So, minus log Ka is 4.74. So, 14 plus 4.74, and concentration of the salt is 0.2 moles per liter. So, log 0.2. What is log 0.2? Log 0.2 can be written as log 2 into 10 to the power minus 1. So, this can be written as log 2 plus log 10 to the power minus 1. Log 2 is 0.3010 and log 10 to the power minus 1 is minus 1. So, 0.3010 plus minus 1. So, 0.3010 minus 1 will be equal to minus 0.699, which can be written as approximately equal to 0.7. So, half into 18.74 minus 0.7 will be equal to half into 18.04. Therefore, pH of the solution will be 9.02. The pH of a 0.1 m solution of NH4Cl is 5.13. Find the dissociation constant of NH4OH. You have to find the dissociation constant of NH4OH, means you have to find the value of Kb. Ammonium chloride is hydrolyzed to give ammonium hydroxide and HCl. 1 mole of ammonium chloride is hydrolyzed to give 1 mole of ammonium hydroxide and 1 mole of HCl. So alpha moles of ammonium chloride will hydrolyze to give alpha moles of NH4OH and alpha moles of HCl. Amount of NH4Cl left behind is 1 minus alpha moles. Now, if the initial concentration of NH4Cl is 0.1 mole per liter, then all these values will get multiplied by 0.1. Now, pH of the solution is given as 5.13. Ammonium chloride hydrolyzes to give a weak base ammonium hydroxide and strong acid HCl. So, the H plus ion concentration in the solution is due to HCl. Now, from the pH value, H plus ion concentration can be obtained. So, log 1 by H plus is 5.13. 1 by H plus will be antilog 5.13. Antilog 5.13 is 1.349 into 10 to the power 5. So, H plus ion concentration will be 1 by 1.349 into 10 to the power 5, which is equal to 0.7412 into 10 to the power minus 5, or approximately 7.41 into 10 to the power minus 6. This is the H plus ion concentration. So, what is the H plus ion concentration after hydrolysis? H plus ion concentration will be same as the concentration of HCl, and concentration of HCl is 0.1 alpha. So, 0.1 alpha can be written as 7.41 into 10 to the power minus 6, or alpha is equal to 7.41 into 10 to the power minus 5. 7.41 into 10 to the power minus 6 divided by 0.1 will be 7.41 into 10 to the power minus 5. Value of KH is equal to concentration of NH4OH at equilibrium multiplied by concentration of HCl divided by remaining concentration of NH4Cl. So, this will be 0.1 alpha multiplied by 0.1 alpha divided by 0.1 into 1 minus alpha. 0.1 cancels, and KH is equal to 0.1 alpha square divided by 1 minus alpha. Now, alpha can be neglected in the denominator as the value of alpha is very low. So, 0.1 alpha square will be equal to 0.1 into value of alpha is 7.41 into 10 to the power minus 5. So, 0.1 into 7.41 into 10 to the power minus 5 whole square is KH. So, value of KH is equal to 5.49 into 10 to the power minus 10. Now, Kb, that is base dissociation constant, is Kw by Kh. Value of Kw is 10 to the power minus 14 divided by Kh is 5.49 into 10 to the power minus 10. Solving, value of Kb is equal to 1.8 into 10 to the power minus 5. A buffer solution is prepared by dissolving 0.2 mole of sodium formate and 0.25 mole of formic acid in approximately 200 milliliter of water. The volume of water varies between 200 to 250 plus minus 50. Means it may be 200 plus 50, that is 250 milliliter, or 200 minus 50, that is 150 milliliter of water. What will be the concentration of H plus and OH minus? Acid dissociation constant for formic acid is given as 1.8 into 10 to the power minus 4. Now, since the volume of water varies between two limits, let the volume of solution be V liters. Now, concentration of sodium formate will be moles of sodium formate divided by volume of solution, that is, this will be 0.2 by V, and concentration of formic acid will be 0.25 divided by volume in moles per liter. Now, formula for pH is equal to pKa plus log salt by acid. Now, concentration of salt is 0.2 divided by V. Concentration of acid is 0.25 divided by V. Volume is same, so volume will cancel. K for formic acid is given as 1.8 into 10 to the power minus 4. So, pKa value for formic acid will be minus log Ka, which is equal to minus log 1.8 into 10 to the power minus 4. The value is 3.745. So, pKa value is 3.745 plus log salt, concentration of salt will be 0.2 divided by acid 0.25. 0.2 divided by 0.25 will be equal to 4 divided by 5. So the equation becomes 3.745 plus log 4 by 5. Log 4 by 5 is log 4 minus log 5. Log 4 is 0.602 minus log 5 is 0.699. So log 4 minus log 5 will be equal to minus 0.097. So 3.745 plus in brackets minus 0.097. Solving, value of pH is 3.65. 3.745 minus 0.097 will be 3.648, which can be approximately written as equal to 3.65. Now pH is minus log H plus concentration, or it can be written as log 1 by H plus, which is equal to 3.65. So 1 by H plus will be anti-log 3.65. Anti-log 3.65 is 4.467 into 10 to the power 3. So H plus ion concentration will be 1 divided by 4.467 into 10 to the power 3, which is equal to 2.238 into 10 to the power minus 4. So this is the H plus ion concentration. Now H plus ion concentration multiplied by OH minus ion concentration is equal to 10 to the power minus 14. Putting the value of H plus ion concentration, value of OH minus ion concentration can be obtained as equal to 10 to the power minus 14 divided by H plus ion concentration, which is equal to 0.44 into 10 to the power minus 10, or shifting the decimal one place to the right. When decimal is shifted one place to the right, here it will be minus 10 plus minus 1. So concentration of OH minus ion becomes 4.4 into 10 to the power minus 11. A buffer solution was prepared by dissolving 0.05 mole formic acid and 0.06 mole sodium formate in enough water to make 1 liter of solution. Acid dissociation constant for formic acid is given as 1.8 into 10 to the power minus 4. Calculate the pH of the solution. This is the first part. And second part is, if this solution were diluted to 10 times its volume, what would be the pH? pH is equal to pKa plus log salt. This is the concentration of salt by concentration of acid, right? What is the value of Ka given in the question? It is 1.8 into 10 to the power minus 4. So this can be written as, now pKa is equal to minus log Ka, and value of Ka is 1.8 into 10 to the power minus 4 plus log concentration of the salt is given as 0.06 mole. 0.06 mole divided by concentration of acid is 0.05 mole. And volume of solution is 1 liter. So concentration in moles per liter will be 0.06 moles per liter. This is the concentration of salt, and 0.05 moles per liter. This is the concentration of acid. Now to solve this, first of all, this becomes 6 by 5 minus log 1.8 into 10 to the power minus 4 can be written as log 1 by 1.8 into 10 to the power minus 4 plus log 6 by 5 can be written as log 6 minus log 5, right? Now this 10 to the power minus 4 goes to the numerator, and this becomes log 10 to the power 4 by 1.8 plus in brackets log 6 minus log 5. Log 10 to the power 4 by 1.8. Log 10 to the power 4 by 1.8 can be written as log 10 to the power 4 minus log 1.8. Now what is log 10 to the power 4? It is 4. So this becomes 4 minus log 1.8, right? अब यहाँ पे ये वैल्यू पुट कर देंगे तो ये हो जाएगा 4 माइनस लॉग 1.8 प्लस log 6 minus log 5. Now 4 minus, taking log 1.8 inside the bracket, this becomes log 1.8 minus log 6 plus log 5. So this can be written as log 1.8 and log 5. So this becomes log 1.8 into 5, and minus log 6 is, it will go into the denominator. So this can be written as log 1.8 into 5 by 6. Now log a into b is log a plus log b. So log a plus log b can also be written as log a into b. Similarly, log a by b is log a minus log b. So log a minus log b can be written as a divided by b. So here there is a negative sign before log 6. So this goes into the denominator, and plus log 1.8 and plus log 5 can be written as log 1.8 into 5. So this is 6 1 ja 6, and 6 into 0.3 will be 1.8. 6 3 is 18. So 6 into 0.3 is 1.8. Then removing the decimal here in the denominator, you will get 10. This becomes 5 1s are 5, 5 2s are 10. So this is log 3 minus log 2. So 4 minus log 3 minus log 2, or opening the brackets, this becomes 4 minus log 3 plus log 2. What is the value of log 3? It is 0.477, and value of log 2 is 0.3010. Solving, the value of pH is 3.824. This is the pH of the solution. So pH of the solution is equal to 3.824. Now second part of the question, when the volume is 10 liters, then what is the effect on the pH? Since here it is the ratio of the concentration of salt and acid is taken, log salt by acid. The ratio of concentration of salt and acid is taken. So अगर वॉल्यूम 10 लीटर हो भी जाता है तो क्या होगा कि log सॉल्ट की concentration है 0.06, तो ये अब डिवाइडेड बाई 10 हो जाएगी, और एसिड की concentration है 0.05, ये भी डिवाइडेड बाई 10 हो जाएगी. Now in this case the volume term gets cancelled. So overall pH remains the same. So in the second case also the pH of the solution will be 3.824. How many gram moles of HCl will be required to prepare 1 liter of a buffer solution containing NaCN and HCl of pH 8.5 using 0.01 gram formula weight of NaCN? Acid dissociation constant for HCN is given as 4.1 into 10 to the power minus 10. Now this combination, that is NaCN and HCl, this is not a buffer solution, but when NaCN reacts with HCl, it forms NaCl plus HCN. Now this HCN which is formed and NaCN, this weak acid and its salt with a strong base, this combination acts as a buffer solution, right? So actually in the presence of HCl, if the amount of HCl is less, then NaCN will react with HCl, forming HCN and NaCl. HCN, weak acid, and its salt with a strong base, that is NaCN. This combination acts as buffer solution. Initial concentration of NaCN is given as 0.01 moles, and let the initial concentration of HCl be X moles. Now X moles of HCl will react with X moles of NaCN to give X moles of HCN and X moles of NaCl. So final concentration will be, HCl concentration will become 0 as it has reacted with NaCN, amount of NaCN remaining will be 0.01 minus X moles, because X moles of NaCN has reacted with X moles of HCl to give X moles of HCN and X moles of NaCl. Now what is the formula for the pH of the solution? pH is equal to pKa plus log salt by acid, concentration of salt divided by concentration of acid, right? What is the pH? pH is given in the question as 8.5. Value of acid dissociation constant is given as 4.1 into 10 to the power minus 10. pKa is equal to minus log Ka. So minus log 4.1 into 10 to the power minus 10, right? Plus log salt concentration is 0.01 minus X. This is the concentration of NaCN divided by concentration of acid, that is HCN. Minus log 4.1 into 10 to the power minus 10 is 9.387. Now how to find the log value? Minus log 4.1 into 10 to the power minus 10 can be written as log 1 divided by 4.1 into 10 to the power minus 10. This 10 to the power minus 10 goes to the numerator and it becomes 10 to the power 10. So log 10 to the power 10 by 4.1. Now log A by B is equal to log A minus log B. So log 10 to the power 10 by 4.1 is equal to log 10 to the power 10 minus log 4.1. Log 10 to the power 10 is 10 minus log 4.1 is 0.613. Solving, this is equal to 9.387. So 8.5 is equal to 9.387 plus log salt by acid. Taking 9.387 to the left hand side of the equation, 8.5 minus 9.387 is minus 0.887, which is equal to log 0.01 minus X by X. This can also be written as 0.887 is equal to minus log 0.01 minus X by X. Minus log A can be written as log 1 by A, or minus log A by B can be written as log B by A. So here 0.887 is equal to log X by 0.01 minus X. From this, X by 0.01 minus X will be equal to anti-log 0.887, which is equal to 7.709. X will be equal to 7.709 multiplied by 0.01 minus X. Solving, the value of X is equal to 0.0088 moles. This is the concentration of HCl which has to be taken in this reaction. So this is the number of moles of HCl which will be taken in this reaction. Calculate the degree of hydrolysis of an N by 10 KCN solution at 25 degrees centigrade. Acid dissociation constant, that is Ka for HCN is given and Kw is given. KCN के जब hydrolysis होगा तो KCN plus water will form KOH and HCN, right? अब अगर degree of hydrolysis को represent करते हैं H से, then out of 1 mole H moles dissociate to give H moles of KOH and H moles of HCN. So if the initial concentration of KCN is 0.1 mole per liter. Now KCN का valency factor of KCN is 1. So its normality is equal to its molarity, right? So here N by 10 can also be written as N by 10, that is 0.1 N. This is the normality, and it can also be written as 0.1 M. This is the molarity. So if the initial concentration is 0.1 mole per liter, then the final concentration will be multiply all the values by 0.1. तो remaining KCN की concentration हो गई 0.1 into 1 minus H. KOH formed is 0.1 H and HCN is 0.1 H, right? Value of KH is equal to KW divided by KA, and value of KH is also equal to concentration of KOH multiplied by concentration of HCl, that is 0.1 H multiplied by 0.1 H divided by concentration of the reactant. Now concentration of reactant is 0.1 into 1 minus H. So putting the value of KH, KH is Kw by K, and this is also the value of KH, and value of Kw is given as 10 to the power minus 14 and K is 7.2 into 10 to the power minus 10. So KH is equal to Kw by Ka, which is equal to 0.1 H into 0.1 H divided by 0.1 multiplied by 1 minus H, and this is equal to 10 to the power minus 14 by 7.2 into 10 to the power minus 10, right? 1 minus H can be neglected in the denominator. This is neglected in the denominator. 0.1, 0.1 cancels. So you get 0.1 into H square, which is equal to Kw by Ka. Solving value of H square is equal to 139 into 10 to the power minus 6. H will be equal to square root of 139 into 10 to the power minus 6, that is 11.79 into 10 to the power minus 3. This is the degree of hydrolysis. Now percentage hydrolysis will be equal to amount hydrolyzed divided by initial number of moles present multiplied by 100. So this is equal to 1.179%, or it is approximately 1.18%. Calculate the degree of hydrolysis of CH3COOK, that is potassium acetate, in 0.1 m and the pH of the solution. Acid dissociation constant for acetic acid is given as 1.8 into 10 to the power minus 5. This question is very much similar to the previous question. Here you have to find the degree of hydrolysis, and what is given molarity of potassium acetate solution is given, that is 0.1 m, and pH of the solution you have to find out the pH of the solution, and acid dissociation constant for acetic acid is given. Now the equation for the hydrolysis of potassium acetate is potassium acetate plus water forms acetic acid and potassium hydroxide. From the stoichiometry of the equation, it can be seen that 1 mole of potassium acetate hydrolyzes to give 1 mole of acetic acid and 1 mole of potassium hydroxide. If the degree of hydrolysis is H, then H moles of potassium acetate will hydrolyze to give H moles of acetic acid and H moles of potassium hydroxide. So amount of potassium acetate remaining will be 1 minus H, amount of acetic acid formed will be H, and amount of KOH formed will also be H. This is when the initial concentration is 1 mole per liter, right? But according to the question, the initial concentration is given as 0.1 mole per liter. So multiply all the values by 0.1. So amount of potassium acetate remaining will be 0.1 into 1 minus H. Acetic acid formed is 0.1 H. Potassium hydroxide formed is 0.1 H. Now KH is equal to Kw divided by Ka. Value of Kw is 10 to the power minus 14 and Ka is 1.8 into 10 to the power minus 5. And KH is also equal to concentration of acetic acid multiplied by concentration of KOH divided by concentration of potassium acetate. Amount of water is constant. So putting the values, Kw by Ka is equal to 0.1 H multiplied by 0.1 H divided by 0.1 into 1 minus H, right? Now 1 minus H can be neglected in the denominator. 0.1 and 0.1 gets cancelled. So here 0.1 H square is equal to 10 to the power minus 14 by 1.8 into 10 to the power minus 5. This 10 to the power minus 5 goes to the numerator. and this becomes 10 to the power minus 9 by 1.8. Solving h square will be equal to 0.056 into 10 to the power minus 7. Now value of h will be equal to square root of 56 into 10 to the power minus 10. 0.056 into 10 to the power minus 7 can also be written as 56 into 10 to the power minus 10. Solving value of h is equal to 7.5 into 10 to the power minus 5. This is the approximate value. Now once you know the value of h, amount of KOH present is 0.1 into h. So 0.1 into value of h, this gives the amount of KOH, that is 7.5 into 10 to the power minus 6. POH will be equal to minus log OH minus, which can also be written as log 1 by OH minus, which is equal to log 1 divided by concentration of OH minus, that is 7.5 into 10 to the power minus 6. Now log 1 by 7.5 into 10 to the power minus 6 will be, this 10 to the power minus 6 goes to the numerator, it becomes 10 to the power plus 6. So POH will be log 10 to the power 6 minus log 7.5. Log 10 to the power 6 will be 6 minus log 7.5 is 0.875. Solving POH is equal to 5.125. So pH will be equal to 14 minus 5.125, which is equal to 8.88. pH plus POH is equal to 14. So pH will be equal to 14 minus POH, and value of POH is 5.125. Solving pH is equal to 8.88. So degree of hydrolysis is 7.5 into 10 to the power minus 5 and pH is 8.88.